Good day to you all. I want to thank the host of this conference for the invitation to speak to you from afar, since I was unable to participate in the conference in person. I was asked to address two themes, and for about 30 to 40 minutes. And the first of these addresses the central topic of a book I published with Oxford University Press 15 years ago. It was called The Taboo of Subjectivity Toward a New Science of Consciousness. And the second book was a more popular book called The Attention Revolution, all about developing the power of a focused mind. And so I was asked, well, what has gone on since what changes have taken place, what progress has been made since the publication of this first book about 15 years ago. Again, the central theme of the book is that there is, especially when it comes to the scientific study of the mind, a type of taboo of subjectivity, or a taboo against subjectivity. There's history to this, so I'd like to give just a brief review of the origins of the modern scientific study of the mind and the challenges they faced. So the study of the mind, the scientific, empirical, experimental study of the mind began roughly 135 years ago, primarily in the United States with William James at Harvard, with Wilhelm Wundt at the University of Leipzig in Germany. And so philosophers had been thinking about the nature of mind, consciousness, the soul, free will, and so on for many centuries. But scientifically, the scientific community had really not addressed the nature of the mind. The scientific revolution began by turning the attention outwards. Galileo is the man we'd really want to focus on, as he directed his attention, his technology, his mathematics, his careful observations, and also his experimentation, directing it outwards to celestial phenomena, the sun, moon, planets, and stars, but also he was a great physicist, the first great physicist of terrestrial physics. And in all of these cases, he was directing the attention outwards to the objective, the physical, and the quantifiable. He applied mathematical analysis to making the rigorous observations, data collection, driven by hypothesis, so he was the first great scientist. And this set the trend for the eventual development of biology and chemistry, multiple branches of physics, and so forth, which had proven a tremendous and unparalleled success by the time we come to the closing decades of the 19th century. And then finally, after roughly 300 years since the time of Galileo, scientists such as Wilhelm Wundt, Titchener, William James thought it's high time to direct scientific inquiry to the nature of the mind. But they faced a challenge in doing so. And that is Galileo, who sparked the scientific revolution, did so in part, a very crucial part, was carefully observing with the best technology, the greatest rigor, precision, and sophistication, the phenomena that he was seeking to understand. Prior to Galileo, there were many, many generations of astrologers who were also interested in these celestial bodies and the relationship with the earth, but they confined their careful observations to the terrestrial correlates, or what they believed to be the terrestrial correlates of the movements of these celestial bodies. But until Galileo, they developed really no sophisticated methods for observing the phenomena themselves. And this is what Galileo introduced to the mix and really started the scientific revolution. So when we come to the closing decades of the 19th century, there are two routes that one may follow. One may insist on the same methodologies in principle of the last 300 years of science, which had proven so tremendously successful, and insist that, well, if we're going to study the mind, let's do so objectively. But of course, mental states, thoughts, images, dreams, emotions, memories, perceptions cannot be observed objectively. They couldn't then, and they cannot be observed objectively now. But you can study the neural correlates as you develop better and better technology, and of course you can examine very carefully the behavioral expressions of different mental processes, states of consciousness, and so forth. So that would be one route, to study the mind indirectly by way of the neural correlates and behavioral expressions. But of course, the other route would be to seek to observe mental events, processes, states of consciousness directly. But this can be done only introspectively. That is, for most of us at least, the only minds that we can carefully observe are our own. And this would take some internal training. You would need to develop attention skills to move beyond folk psychology and casual observations or experiences of one's own mental states to try to develop a rigorous mode of observing, experimenting with, exploring the nature of consciousness, states of mind, causal patterns within mental processes. But that would be a very different agenda, to primarily focus the attention inwards, which would be breaking away from tradition of the last 300 years, which is all looking outwards, but it would be keeping with tradition in the sense of carefully observing and, if possible, experimenting with the phenomena you're seeking to understand. So Wilhelm Wundt, Titchener, William James, they felt, let's do a truly scientific approach and let introspection be the primary mode of exploring the mind, and then secondarily study behavioral expressions and the correlates taking place within brain activity. They tried that for about 30 years, but they really developed no sophisticated means for developing attention skills, which are crucial, no sophisticated methods of introspection. In fact, they really left the observing itself in the hands of amateurs, while the scientists put questions to people who were just taken off the street and asked to do very primitive introspective observations. Well, after about 30 years, it was found this was not proving to be a very effective method. And in 1910, James Watson, who was seminal in starting the whole movement of behavioral psychology, decided to take the other route. He said, let's abandon introspection. And not only that, but let's not even talk about subjective mental states like perceptions, memories, emotions. Never speak of consciousness. We can't measure these objectively. And so let's just do what we're good at, what we have been good at for the last 300 years, and that is, let's study behavior. They didn't have the technology really at that time, this is more than 100 years ago, to study the brain with any kind of sophistication, but they could certainly study behavior, animal behavior, human behavior, and so forth. They could interview people. And so for the last 100 years or so, that approach has absolutely dominated the scientific study of the mind, in psychology, neuroscience, and so on. And so a lot of progress has been made in understanding the correlations between behavioral expressions of mental states and the mental states themselves. And of course, over the last 20, 30 years, there's been a great growth in understanding the brain due to the finer technology that's been developed, and very specific and sophisticated knowledge of mind-brain correlations. So this is all to the good. But as William James pointed out more than 100 years ago, we're simply in the dark, with no real understanding at all about the actual nature of the correlations between our subjective mental experience and the activities in the brain. How are they related? Are they the same? Is the brain solely responsible for generating all mental states, which is widely assumed nowadays, but with no compelling logic or empirical evidence? We've remained completely in the dark about the actual nature of mental events. And why? Because we're not looking at them. Scientists, up until Galileo, were completely ignorant about the actual nature of the moon, the planets, the stars, the sun. They had no sophisticated means of observing them. Well, nowadays we have an enormous body of knowledge about the nature of these celestial bodies, their origins, their eventual destiny, how they causally interact with the Earth, with other celestial bodies, with space-time and so forth. But that all comes from precisely observing, with greater and greater sophistication, with finer telescopes and so on. That's been the hallmark of the great success of science for the last 400 years, but it's not the hallmark of the scientific study of the mind. We've learned a lot about brain, a lot about behavior, but the nature of mental events remains completely in the dark. Something's missing. Let's follow a parallel here, and that is over the last 90 years or so, with the rise of quantum physics, under the guidance of people like Einstein himself, Werner Heisenberg, Niels Bohr, Erwin Schrödinger. About 90 years ago, Heisenberg and others discovered that there was something about the very nature of measurement that seemed to influence the quantum systems that were being investigated. That prior to measurement, all you could say that was there was simply a range of possibilities, a probability function, which is completely an abstraction. But you could not say that an electron existed here, or it was here, or is moving at this velocity, and so on. It was only when you made the measurement that a range of possibilities or probabilities crystallized into an actual reality of a photon, a proton, electron being here or there and causally interacting in certain ways. So what's the nature of measurement? And more deeply, what is the nature of the observer? Because we can't really speak of measurement without an observer being involved. If you have simply a cup sitting on a table, the cup isn't measuring the table, the table isn't measuring the cup. It takes a conscious observer to actually make a measurement. So what's the nature of the conscious observer, and how does that relate with measurement in the field of quantum physics? They didn't know 90 years ago, and they don't know today. There's been no progress at all. Because in order to make progress, you would have to understand the nature of conscious observation, which would mean you'd need to know the nature of the mind, the nature of consciousness, and how it interfaces with physical phenomena. But neither in physics, nor in psychology, nor in neuroscience are there any sophisticated means for directly observing, exploring, experimenting with states of consciousness themselves, let alone exploring multiple dimensions of consciousness. Now in physics, they speak of sometimes 11 dimensions of space. They speak of space-time and very, very esoteric things. But when it comes to the mind, it's almost like we're flatlanders, like people who apparently at some time believed the earth was flat. When it comes to the mind, we're neurocentric. We can only think of the mind in terms of neural correlates, and then often reducing them to neural correlates, but with no justification. So this was the situation when I published this book, The Taboo of Subjectivity, 15 years ago. And I wish I could say that there's been great progress, that the scientific community's become much more open to investigating the mind from a first-person perspective, and we're moving beyond the research of simply scientists studying the brains and behavior of meditators, for example. All these studies of mindfulness showing the practical benefits, health benefits, creativity benefits, and so forth, all very good. But you don't understand the nature of meditation just by studying behavioral correlates or activities in the brain, any more than you'll understand mathematics by studying the brains and behavior of mathematicians. If you want to understand mathematics, you have to learn mathematics. If you want to learn the nature, the power, the potentials of meditation, for exploring the nature of the mind and tapping the inner resources of the mind, you have to meditate. You cannot understand physics by studying physics textbooks or the behavior of physicists. You have to practice physics, and that's the only way you'll understand. Well, why should this be any different when it comes to the mind? So I wish I could say there's a lot of progress, but frankly, the resistance, the inertia is tremendous. There's a great deal of resistance among psychologists and neuroscientists of allowing introspection to take a prominent role in the scientific study of the mind. And it's brushed away very commonly with the belief, well, introspection, after all, is subjective. It's not scientific. It doesn't lend itself to third-person corroboration. It's just not scientific. To be scientific, we have to focus on the physical, the objective, the quantifiable. Otherwise, it's just subjective impressions which can be very misleading. Well, that's been the excuse thus far. But I'd have to say it's a very lame excuse for many reasons. I'll give one. I'll give two, but first one. And that is when Galileo, the first great scientist, the person who sparked the scientific revolution back in the early 17th century, when he was looking through the lenses, there were just two lenses in his first telescope, with magnification of only about 8 power. But he made extraordinary discoveries, and he developed better telescopes as he continued his research. But if one were a skeptic, one could say, Galileo, you're not really observing the sun, the moon, the planets, or the stars themselves at all. All you're observing are visual appearances, impressions, that are generated by your brain. Obviously with the help of some, nowadays we'd say photons or electromagnetic fields being generated from these celestial bodies, striking your retina and triggering this very complex electrochemical sequence of events. culminating in the visual cortex. But you're not observing the sun and moon and so forth. You're just observing mental images. And mental images are just products of your own mind or your brain, as you wish. But you're not seeing those celestial events themselves. So why should we trust your observations, which are actually very subjective? It's not scientific. Those phenomena out there in the deep space, they don't have color. Color arises independent upon, we say nowadays, the visual cortex. And again, visual impressions are misleading. Nowadays, all psychologists know that. So they could have actually torpedoed the rise of modern science from the time of Galileo. And that pertains not only to his celestial observations, but his terrestrial observations. All he's seeing are impressions generated by his brain, influenced by sound waves, photons, and so forth. They could say, well, it's hopelessly subjective. Even if other people observe as well, people make mistakes in common. Well, thank goodness nobody put the brakes on his research. Even those qualms have a certain rationale to them. So the notion nowadays that the scientific study of the mind must not include observing mental events, I'd have to say, frankly, it's absurd. The notion that they're somehow intrinsically misleading, well, visual impressions can be just as misleading. Auditory impressions, sounds, can be also misleading. There's lots of research on that. So that objection just doesn't hold together. It doesn't stand up to analysis. But there's another one. And that is the foundations of all of modern science, since the time of Galileo, has been mathematics. Galileo was a very fine mathematician. He was employed at the University of Padua as a mathematician. Einstein, great mathematician. James Clerk Maxwell, great mathematician. And nowadays, you can't go into any field of sophisticated science without drawing on mathematics. Mathematics is the foundation. So what do mathematicians do? They often sit by themselves, and they work through theorems, they come up with proofs, and according to some of the greatest mathematicians of history, including Roger Penrose, perhaps the greatest mathematician living nowadays, mathematicians are making discoveries. They're not just coming up with conceptual creations, fabrications, abstract proofs. They're actually making discoveries in the domain of reality that is mathematical in nature. But when they're making these discoveries, it's entirely subjective. They're working through the theorems, their proofs, their analyses, and then at some point they come to a proof. And the proof takes place not when you've written something on a chalkboard or something on your computer, some equation. The proof comes when you understand it, when you gain insight. And then you show your theorem, your proof, what have you. You show them, if you're a very highly trained mathematician, you show your work to another mathematician. The other mathematician, in this peer review, checks your work, and then maybe the light comes on. Oh, fantastic, you've made a great discovery. And then more and more people read it individually, and they're corroborating each other's insights, and then it gets published in their peer-reviewed mathematical journals, and the people who make the finest discoveries, the most important discoveries, earn the Field Medal, which is like a Nobel Prize for mathematics. But it's all subjective. But among highly trained mathematicians, they can intersubjectively critique and validate each other's discoveries. But no one but a highly trained mathematician is in a position to evaluate their work one way or another. They can't refute it, they can't validate it, any more than people who are not highly trained in astronomy can validate or repudiate the most sophisticated discoveries in astronomy today, like the existence of exoplanets and so on, black holes, dark matter, and so on. So if the very nature of mathematical inquiry is by nature subjective, but is so robust that it's the foundation for all of modern science, then we can ask, why couldn't the introspective investigation of the mind, which can, without any question, give rise to discoveries that can be corroborated by other highly trained or even moderately trained contemplatives, why couldn't this be just as rigorous, as decisive, as conclusive, and scientific as mathematical inquiry? There really is no reason. So it's high time to make the scientific study of the mind truly scientific, and that is join all the other branches of the sciences and carefully observe, experiment with as much sophistication as possible the phenomena you're trying to understand. Now, scientists haven't done this. Philosophers think about the mind a lot, but they don't observe it with any degree of sophistication. So then we can ask, okay, if scientists aren't doing it, and philosophers aren't doing it, has anyone in human history engaged in such rigorous, decisive, revealing, first-person inquiry into the nature, the potentials of the mind? And the answer is yes, for centuries, even for millennia. But these people are not called scientists, and they're not so much philosophers, they are contemplatives. Hindu contemplatives, Buddhist contemplatives, Taoist, Jewish, Christian, Muslim, all over the world. Very sophisticated methods have been developed, but in the context of religion, which means they've been ignored thus far. Scientists are very happy to study the behavioral, the physiological, the psychological effects of meditation. But in Buddhism, for example, the primary reason to meditate is not health benefits or creativity in the workplace or stress reduction. It's to understand the nature of the mind, the inner causes of suffering, the inner causes of genuine happiness, to explore multiple dimensions of the mind, to fully tap the inner resources of the mind. This is perhaps the oldest branch of science, but it's not found in the scientific community, it's found in contemplative communities worldwide. So, I think the time is ripe to abandon this taboo against subjectivity, which means not to abandon the taboo against subjective bias, but rather the refusal to observe non-physical events. And that's what mental states, processes, dreams, emotions, desires, thoughts, memories, and so forth, they're non-physical. You can't measure them physically, and when you do observe them, they have no physical attributes. Shouldn't that be enough to persuade us that mental processes are part of nature? They're causally efficacious, but they're not physical. Any more than the laws of mathematics are physical, any more than information, meaningful semantic information that you're hearing from me right now. This is not physical. It has no mass, no location, no spin, no momentum. Information, we're living in an information age. Let's start embracing that. Information itself is not physical. So, this is a work in progress.